Okay, so I'm kind of testing out the sound quality, but I did want to go over a visual example of what I see happening a lot when we solve equations in statements. So I'll start out with my seesaw example, or really maybe a balance or a scale. So if you have a balance, so this is the scale. Oh, actually, let me draw a straight line. I'll make it red, we'll say. So there's our scale. Somewhere in the scale, you have the middle point. It's called the fulcrum. But that determines the balance point. So it's going to basically determine the left and right sides of this line. So for example, let's say my fulcrum, which is normally a little triangle. Actually, let me see if I can do. Let's say the fulcrum is way over here. Didn't really work. Try that again. Not sure why it didn't work. Would be my shape pen. Oh, shape pen. Let's try that one more time. Maybe I didn't cross them. Oh, there we go. So let's say the fulcrum of this particular line is way over here. That would be where the equal sign is. So again, that is the same exact thing as saying the equal sign. So in our equation lingo, this would be the equal sign right here. So we may say, I'm going to use bags of sugar. All right. So let's say we have a bunch of bags of sugar. So this bag of sugar right here, that bag of sugar is 10 pounds. We have a little tiny bag of sugar here that's only 5 pounds. And then we have a big bag of sugar here that's like 20 pounds. Then let's say we have a couple more little bags of 5. And then maybe another 10. So we got all these bags of sugar on one side. And if we look at them, it's 20 plus 10 plus 10 would be 40, plus 5 and 5 would be 55. So all of that equals 55 pounds. So let's say on this side, we have a gigantic, huge bag of sugar that's 55 pounds. So it's in balance. The right side of the scale is 55 pounds. The left side is 55 pounds. So that equal sign would basically say the left side is 55, the right side is 55. So when I see people in an equation adding, like sometimes when we try to combine, so I'll give you an example. So now let's say my equation is 3x plus 2 subtract x equals 12. Right? Sometimes what I see is I see people doing this and they say, okay, well, I need to add x here and I need to add x here. We can't do that. That's like adding 2 bags of sugar to the left side of our scale. It's just going to make that side a lot heavier. You can never do 2 things to the same side. So if this is the middle of our scale, the equal sign is always the middle, even if it's not in the middle. We can't do plus x and plus x both on the left-hand side. Just like we couldn't try to keep our bags of sugar in balance by coming up here and saying, well, I'm going to add a 5-pound bag here, and I'm going to add another 5-pound bag over here. I can't do that. That would just give me too much sugar on the left side. Or I can't subtract 5 here and subtract 5 here. I'm taking them off of the same side of the scale. It doesn't work. Then I would have 45 pounds on the left and 55 pounds on the right. That doesn't work. What I need to do is I need to say, okay, well, I can subtract. I don't know if this is going to erase my big line or not. Nope. Good. I can subtract 5 from the left side, but if I do that, then I need to also subtract my 5-pound bag of sugar from the right side. Now they're in balance. Now I have 50 pounds on the left and 50 pounds on the right. So just remember, the equal sign acts as kind of the middle of the seesaw, even if it's not right in the middle. It separates the left and the right side of your scale or your seesaw. If you do something on one side of this equal sign, then you need to do something on the other side. So if I add x on this, okay, so we'll need to erase that one. If I add x on this side, whoops, I did 3. If I add x on this side, then I would have to add x also on this side, which really doesn't accomplish anything. That's silly for me to move the x over to the right side. So I don't need to add x and add x. What I would do, once I get rid of all of these, I would just combine these two terms right here, the two like terms. I don't need to add x to one side and then add it to the other side. I just say, oh, well, 3x subtract x is just 2x. And then I would bring down the 2 that I didn't touch, and that would just equal 12. Now is when I could go ahead and say, okay, well, at this point, I see that I need to get rid of this 2. Again, I need to do it on both sides of the scale, the equal sign separating the left and the right sides. And I need to say, if I subtract 2 on the left, I subtract 2 on the right. It gives me 10. Now I still have the 2x. If I divide here by 2 to get rid of it, I need to divide over here to get rid of it. So I get x equals 5. And that would be my final solution. So we check. Correct. Actually, technically to say check, I should really go up and check it. So let's do that. So if x equals 5, let's see what my original equation was. 3x plus 2 subtract x equals 12. 3x plus 2 subtract x equals 12. If x is 5, then 3 times 5 plus 2 subtract 5 better equal 12. That would give me 15 plus 2 subtract 5 better equal 12. And that would give me 17 subtract 5 better equal 12. And yes, 17 subtract 5 is equal to 12. So I know I solved that correctly. Again, it's really just to test out the audio quality, since it hasn't been good. But maybe that actually